All right, so video 2 here, we're talking about a mean now. So estimating the margin of error for a mean. And again, this should go a little bit smoother because it's very similar to the first video on proportions. So we're doing this resulting from a random sample of size n. So first thing we do is we need to simulate the distribution of the sample mean for many random samples of size n taken with replacement from the original sample. Again, all that means is we're creating a simulations or a distribution from a bunch of simulations. And again, the same things have to keep true for when you got the sample value in the first place. And then once you get that simulation, you're going to take your standard deviation and multiply it by 2. And that's going to give us our margin of error. Okay, so same story holds for means as it does for proportions. Understanding that this entire year, when we get to the end, there will be proportion problems and mean problems. So be aware of that. Okay, so here we go. Example 2 is the stream oxygenated. The level of dissolved oxygen, DO, in a stream or river is an important indicator of the water's ability to support aquatic life. A researcher measures the DO level at 15 randomly chosen locations along a stream. Here are the results in milligrams per liter. So there are your 15 values. The sample mean for these data is X bar equals 4.77. This is our sample mean. This is our sample value. This is our estimate. Now again, notice the notation X bar. That is the symbol for sample mean. So it says the dot plot shows the distribution of the sample mean DO level for 300 random samples, size 15, taken with replacement from the original sample. Okay, so there you go. So it says, A, use the results of the simulation to approximate the margin of error for the estimate of the mean DO level in the stream. Margin of error. So to find the margin of error, we're simply going to take 2 times this standard deviation of 0.246. And when you do that, you get 0.492. Now, because we're doing a mean problem, means share the same units as your data. So if your data is in milligrams per liter, your mean or your margin of error is also in milligrams per liter, 0.492 milligrams per liter. And now we interpret the margin of error. So here's our interpretation. We expect the true mean DO level in this stream to be at most. So there's your words, to be at most. That's your cue for a margin of error, to be at most 0.492 milligrams per liter from the estimate of 4.77 milligrams per liter. It's a little redundant to put the units twice, so if you don't put them twice, it's okay, but you know, I'm all about units and labeling. Okay? And there we go. So again, just to kind of talk about, I'll do it up here in red. So just to kind of future forecast because we got some time. So then if we were trying to estimate the actual true value, right? The actual true mean value, then we would say, okay, well, we're going to take this 4.77 and subtract 0.492 and add 0.492. Okay, so 4.77 plus or minus 0.492. So that would give us an interval of 4.278 to 5.262 milligrams per liter. And that would be the interval that we would say we're pretty confident that the true mean DO, dissolved oxygen level, is within that interval. Okay, and again, that's later on in chapter 7. Okay, all right, great job. Good luck on the homework.